Hey guys, here's some videos going through some open response practice problems for your midterm. First off, we got tickets to a local movie sold for $3 for adults, $150 for students. 170 tickets were sold for a total of $480. We don't know how many tickets of each type were sold. So I'm going to say that X is the number of adult tickets. I'm going to say that Y is the number of student tickets. I know that the cost was going to be $3 times the number of adults plus $150 times the number of students. And also a really important equation to know, because now I've used cost. Oh, and they give me that information. So that's $480. 170 tickets were sold. Okay, so that's tickets sold. And that's equal to the number of adults, which is X, plus the number of kids, which is Y. Okay. I now have this set up in a pretty good format. I'm going to multiply the bottom equation by 3 to make my x's be the same so I can use elimination. So this top one doesn't change, so it becomes 480 is equal to 3x plus 1.50y. The bottom equation, 170 times 3 is going to be 510, is equal to 3x plus 3y. When I subtract these two, I get negative 30 is equal to negative 1.5y. And that means that y is equal to, when I divide negative 30 by negative 1.5, I get 20. Okay, and if y is 20, based on this equation, that means that x has to be 150 for that to be true. And that's what I'm looking for, the number of adult tickets. Number 2, a group of 68 people attend a ball game, 3 times as many children as adults. Okay, I'm looking for the number of children, number of adults. 3 times the main number of children. So 3 times the adults is equal to the children. That's a little bit confusing. It feels like it should be backwards. But I just need to think that there are more children than adults. There are 3 times as many children as adults in the group. That's really confusing, huh? And 68 people attend the ball game. Okay, that's another one of these. This is a classic setup. We have those two things being added together is equal to 68. This is a great problem for substitution to find the number of children, number of adults in the group. We have a plus 3a is equal to 68, which means that 4a is equal to 68. When I divide both sides by 4, we get a is equal to 17. And if 3 times a is the number of children, that means that children is equal to 3 times 17, or 51. For number 3, we got tickets to a puppet show, combination of child tickets and adult tickets, using A and C for numbers of tickets. This seems to be a repetitive pattern here. We know that we're looking at A times, or A plus C, that's the total number of tickets, is equal to 7. We also have a cost equation, so that's 2 adults and 4 per child is equal to $24. This is a great one for elimination. Again, multiply my top equation by 2 to make it similar to my bottom equation. We get 2a plus 2c is equal to 14. When I go to subtract, I get 0. We get 2c is equal to 10. That means that c is equal to 5. And if c is 5, that means that a is 2 to make 7. For all of these, you really should be having some kind of a written answer saying, like, The number of adult tickets was 2. The number of children's tickets was 5. For the sake of doing this very quickly, I'm just trying to get this out of here quick. For number 4, we've got an object thrown into the air. I'm trying to first find the maximum height. This is a really big deal. This is something that you definitely need to know. And we also need to know is that the maximum x value always occurs when x is equal to negative b over 2a. We've talked a lot about finding the vertex of a parabola. This is always where that vertex is. This is a really big deal, something that you definitely need to know. So if h is equal to negative 16t squared plus 32t, my a value is negative 16, my b value is 32. My maximum is definitely going to occur, and I guess this should be a t instead of an x, but that's okay. At negative 32 over 2 times negative 16, negative 32, it should occur at a time of 1 second. Okay, this is the maximum time. What I then have to do is plug this in. By the way, we just answered part B. The maximum height for this. So h is equal to negative 16 times 1 squared plus 32 times 1. When I plug those in, negative 16 times 1 squared is negative 16 plus 32, that's going to be 16 feet. I can get my answer. A rock is thrown from the top of a tall building. Distance between rock and the ground, t, is given by an equation. How long after the rock is thrown is it 410 feet from the ground? Okay, 410 feet from the ground means the d, because that's the distance from the ground. So I'm going to write this equation as 410 is equal to negative 16 t squared minus 4t plus 412. I also know to solve any quadratic, the first thing I always want to do is to bring that to the other side. So I get 0 is equal to negative 16t squared minus 14t plus 2. I wouldn't mind dividing everything by negative 2 to make this a little bit comfortable to deal with. And that makes my equation, before I really dive into this, 8t squared plus 7t minus 1. And by golly, that looks factorable. And this is a factorable thing. So what I'm going to do is factor this guy. I've got a times c is going to be negative 8. T squared, b is going to be positive 7. Two things that add up to negative 8, multiply negative 8 and add up to positive 7 are going to be 8 and negative 1. So if I were to rewrite this, it becomes 0 is equal to 8t squared plus 8t minus 1t, and then minus 1. I change colors so we can see this a little better. I can take an 8t out of the first two, and I get t plus 1. Take a minus 1, and I get t plus 1. That leaves me with 0 is equal to t plus 1 and 8t minus 1, which gives me t is equal to negative 1 and t is equal to positive 1 over 8. Time after it's thrown, the negative answer doesn't really make sense. At 1/8 of a second, it is 410 feet from the ground. And we all know we can count that quickly, so keep an eye out. Just as a second thought, if you were kind of curious about the maximum height of this, we can get kind of a funny answer for this. The vertex of the parabola formed by this would be at negative b over 2a. and that's going to occur at positive 4 over negative 2 times 16 is 32. So negative 1/8 of a second, which doesn't really make sense. So we can kind of ignore that. I just want to get that stuck in your head because that's kind of a big deal. Okay, Tom has a collection of 30 CDs. Nida has a collection of 18 CDs. Tom is adding 2 CDs a month to his collection. Okay, so we're going to have a Tom equation. So he's got 30 CDs now plus 2 per month. Okay. Nida is starting at, or Nita, I don't even know. 18 CDs plus 4 CDs per month. I'm going to say M is months. Sketch a graph to find when they'll have the same number of CDs. Well, these graphs don't really go well for us because we can't really see the points we need, but we'll do the best we can. So 30 plus 2 per month, we're going to start at 30. This is Tom. And after 5 months, he's going to have 10 more, so at that point I can do. After another 5 months, he's going to have another 10 more. At that point I can do pretty nicely. Hey, look at that. That's pretty good. And then I'll do Nita or Nida. She's got 18. Cool. I can't really see what that is because that's like here-ish. Although after 3 months she hits 30, and that's a nice number on this graph. And my next nice even number is going to come when she hits 50, because that's 20 later. So at 8 months, she hits 50. And it looks to me sometime between 5 and 6 months they pass. Realistically, that might be 6 months. I can't really tell based on my graph because graphing is not a good way to actually solve this problem. But it's a nice visualization for this. What might be better is if you set the two equations equal to each other, because you want to know when Tom equals Nida. And that would be 30 plus 2m is equal to 18 plus 4m. So we get 12 is equal to 2m, and m is equal to 6. But that's pretty close to what we got based on our graph. Okay, we've got a ballpark question. $5 for each ticket and 1,400 concessions. Must pay $2,000 and each worker's $1,600. Each fan gets a free bat that costs them $3 per bat. How many tickets must be sold to break even? So here's a profit question. Break even means you don't lose any money. So we're going to talk about income and expenses, and our goal is going to be to make those equal to each other. Charges $5 per ticket, okay? So that's $5 times the number of people who come in. 1,400 concessions, so they sell $1,400 in food. Although I feel like that should be based on number of people too, but that's okay. They must pay its players $2,000 and pay all other workers $1,600. Each fan gets a free bat at $3 per bat. So that's $3 times the number of people. So what we've done is we said that income has to equal expenses. That's what that break-even word means. And what we're going to do is basically solve this equation. I'm going to try to bring the x's over to the left, so minus 3x. And I get 2x, and I bring my numbers over to the right. 2,000 plus 1,600 is 3,600. minus 1,400 is going to be 2,200. It looks like the break-even point is going to be 1,100 tickets. So that means if I sell 1,100 tickets, I make as much money as I spend. Next up, we've got a fencing problem. I'm going to start off by drawing my museum. And we're going to set up our fencing in a rectangular space. We know that the total fencing is 120. I'm going to set the vertical parts equal to x. And you might remember when we set these problems up before, we've got the total minus 2x for that third side. That's the big deal in setting this up. It's always going to be set up pretty much the same. If we had 3 pieces to divide this up into, we'd have 120 minus 3x instead of 120 minus 2x. But here we have 2 verticals. The area for this is going to depend on what we choose for that x to be. I guess part A is just trying to get you to set up this expression. Unless it's trying to get the maximum area. I'm not really sure. We have to find that as part of the maximum area, so we might as well just do this problem as a whole. So we've got an area y is equal to length times width. In other words, we're looking at, and I'm going to switch the order here as I multiply, so 120x minus 2x squared, or negative 2x squared minus plus 120x. We know that the maximum occurs at negative b over 2a. So we're looking at negative 120 over negative 4, which is 30. So 30x would give us the maximum area. That means that the area is equal to 30 times 120 minus 60. 30 times 60 is going to be 1,800. And going backwards, if that's 30, 120 minus 2 times 30 is going to be 60. So that gets us both pieces a little bit out of order from the way the problem is written. We've got a carpenter making a brace. Brace is going to be in the shape of a right triangle. The hypotenuse is 41. The longer leg will be 31 inches shorter. I'm going to draw a picture of this. So hypotenuse is 41. Let's call this the longer leg, and this the shorter leg. So x minus 31. Quadratic equation for this, because this one also makes a lot of sense to do. X squared plus x minus 31 squared is equal to 41 squared. And they'd like us to use factoring to solve this equation. I don't think they'd particularly love the way that I would try to do this problem, because I don't want to factor this, but I'll humor the creators of this problem and pretend that you'd actually do something this way. We got x squared, and then we've got x minus 31 times x minus 31. 41 squared. I'm going to open Desmos to solve that baby for me. Or maybe even just Google. Oh good, I typed in 41. It told me 41 is a number. So that's going to be 1681. What, you didn't have that in your head? And then I'm going to do the other piece of this, which is to multiply stuff out. We get x squared plus x squared minus 31x minus 31x 31 squared is 961. Actually, that one I knew. And we got 1681. Let's combine some stuff. I'm going to have 2x squared minus 62x when I bring that over to the other side. We get negative 720 equals 0. Okay, I'm going to divide everything by 2 because that's going to be much nicer. 31x is equal to 720 divided by 2. Oh, sorry, minus 360 is equal to 0. So things that multiply to negative 360 and add up to negative 31. Okay, I'm going to start by 1. 1 times negative 360, nope. 2 times negative 180, nope. 3 times negative 120, nope. 4 times negative 90, nope. 5 times negative 72, nope. 6 times negative 60, this will be negative 54, no. 7 doesn't work. 8 times negative 45, nope, that one doesn't work either. How about 9? 9 times negative 40, and there we have our winner. I'm going to change colors so we can keep track of this. X squared plus 9x minus 40x minus 360 equals 0. And we get x times x plus 9 minus 40 times x plus 9 is equal to 0. X minus 40 and x plus 9 is equal to 0. That means I have a length of 40 or negative 9. Which one of those do you think doesn't make sense? The negative one, if you didn't guess. So the length of the longer brace would be 40, and the shorter brace would be 40 minus 31. You might also have figured this out if this were a Pythagorean triple, which it is, which is 9, 40, 41. Although most people don't have that random knowledge in their heads. Number 10, we're looking at a box. Another guarantee of something you're going to see on your exam. We've got an equation for us. It can be expressed as a product of 3 linear factors. And we've got to factor this polynomial. Well, the first thing I'm going to do is to, well, it also tells you what the width is. But I'm going to go back to what we have here and write this as x times x squared minus 6x plus 8. It tells us the width of the box is 2 minus x, which really means that we're dividing this by 2 minus x to get that. So we could do this using long division. X squared minus 6x plus 8, and that's really negative x plus 2. To get to x squared, that'd be times negative x. When I multiply down, we get x squared and minus 2x. When we subtract, we get negative 4x. I bring down the 8, and then we have plus 4. And we get negative 4x plus 8 with no remainder. It's kind of an awkward way to factor this because they're determined that x has to be positive, which is kind of silly. So that'd be 2 minus x and negative x plus 4. A better way to think about this might be to just factor this and let x be a negative number based on the way this problem is written. If we're trying to graph this function, okay, so we've got an x-intercept at 0, we've got an x-intercept at 2, an x-intercept at 4. We know that V is the volume, and these would be 3 places that the volume is equal to 0. What you might think about is that this is coming from one of these ridiculous box problems where we're cutting a corner out of a box where this is x. If we don't cut anything out, well, the volume is 0. If we cut 2 out, that probably would kill this entire part, which means that the box would be 0. And if we cut 4 out, well, that probably would be this entire part up top, which means the box would be 0 also. So those are 3 places that the volume equals 0. A realistic domain, I'm going to finish graphing this first. We know that this is a positive graph with positive end behavior, so we're going to go up, and it's going to look something like this. The only domain that really makes sense for this is x values between 0 and 2. Based on this, anything above 2 would either give us a negative value or something like that. We don't really know why this equation exists like this, so we can't say that this domain doesn't make sense. But because of what we expect to be true about this, which is formed from cutting the corners out of things, that domain makes at least some sense. Maximum volume for this you got to use a graphing calculator for. We're going to go to the y equals menu, and for y1, you type in the equation, x times 2 minus x times negative x plus 4. Or better yet, type in the original equation. That way, if you factored wrong, you can still do really well in this part. So that was x cubed minus 6x squared plus 8x. And what you're going to do from there is go to second and trace. That brings up the calc menu. You want to go to max. It's going to ask for a left bound. You're going to move the cursor to the left of where you see on the graph. The graph probably looks something like this. So if you go somewhere, you're trying to find this point, so if you move your cursor somewhere to the left of it, like even here, you're fine. Then it's going to ask you for a right bound. You're going to move the cursor somewhere to the right and press enter. And then it's going to ask you for a guess. You're going to try to guess that and press enter as close as you can. The way that your calculator does this is it kind of goes between those and figures out what is going on along the way. Basically, it's a rapid guess and checking machine. And in terms of getting that point, that's a great way to do that. Without a graphing utility, there's no way for you to do this without some calculus, which you don't currently have. Whatever the x value would be what you're cutting out of the corner. The y value there would be the volume. I can't spell today. There we go. So if I were to go on to Desmos to basically do the same thing, and that's going to be x cubed minus 6x squared plus 8 x. Oof, I got worried for a second there. And I get an x value of 0.845 and a y value of 3.079. That's the maximum volume for this box. Very useful to store things in. Volume of a cubic feet of a storage chest can be expressed by the product of three dimensions. It gives a depth of x plus 1. Okay, this is another divide and solve problem. This one's a little bit more straightforward for us. So if I do x plus 1, x cubed minus 3x squared minus x plus 3. Dividing here, we're going to get x squared. So it's x squared plus, x cubed plus 1x squared minus 4x squared when I subtract. Bring down 1, so that's minus x. So that's going to be minus 4x. Multiply down, we get minus 4x squared minus 4x. When we subtract again, I get 3x plus 3. And that's going to be plus 3 up there. So far we're looking at x plus 1 times x squared minus 4x plus 3. And that's going to factor into x plus 1 times x minus 1 times x minus 3. What are the other dimensions? So we said the depth was x plus 1 is equal to 6. That means that x is equal to 5. The other dimensions are 5 minus 1 is 4, and 5 minus 3 is 2. For number 12, we're looking at some kind of another quadratic problem. We've got to do some graphing and some finding zeros. I feel like that is a little bit out of order there. I'm not sure that this is definitely not factorable. So I don't know, maybe let's find the vertex first. That's going to be at negative 145 over 2 times negative 16. And when I do that out, so it's negative 145 divided by 32. We get, negative 4.53. Why is that negative? That should be positive 4.53, okay. And if I plug that in, so by plug that in, I mean y is equal to negative 16. 4.53 squared plus 145 times 4.53 plus 7. We end up at negative 16 times 4.53 times 4.53 plus 154 times 4.53 plus 7. I get 376.28. Graphing this doesn't seem to make a lot of sense here, so I'm not even going to bother with that. Zeros of the function. Well, I found the vertex, so that might come into play later on. So that's where 0 equals y. Negative 16x squared plus 145x plus 7. I'm going to use quadratic on this. And in doing so, we get, so that's negative b over 2a. So negative 145 over negative 32. Hey, we already did that part. That's 4.53. Plus or minus the square root of 145 squared minus 4 times negative 16 times 7. Okay, let's do that part out. So we've got 145 squared minus 4 times negative 16 times 7. And I think my calculator messed up because I'm using my phone. When done correctly, that should end up being plus or minus the square root of 21,473. That's also over negative 32. The square root of that so we got 4.53 plus or minus, that's 146ish divided by 32, 4.57. And when we do that, we should get something like negative 0.04 and positive, I don't know, it's about 9.1 as our two zeros for this function. So that's up all the way up here. What do the zeros represent? Height of 0. We're talking about a rocket or something here. Toy rocket. So these are the times when rocket is on the ground. The first one's negative, so the negative value doesn't really make a lot of sense. That'd be before we launch the rocket. And the reason for that is that we're launching the rocket from 7 feet off the ground. 9.1 seconds makes a lot of sense. That means the path of the rocket went up and then down in 9.1 seconds. I'm wondering if you were supposed to graph this on a calculator and then just translate the graph onto here. I think that was the intent here, although I don't find that to be a useful exercise or a useful use of your time, but that's okay. So 9.1 seconds would be the zero that's realistic, and that makes sense that after 9 seconds it hits the ground. How high does the rocket fly before hitting the ground? Well, that's going to be that vertex. So if you want to think that the vertex is the max, and we found that much earlier in the problem, the vertex is going to be at 4.53, comma 3, 76.28. You might notice that this is a big deal. It's going to continue to come up again and again.
Okay, guys, here's a revenue problem. We're going to have one of these almost exactly like this on your midterm. So this is a really important one to understand how this is set up. Also because it's a really strange setup. I've never quite seen a problem like this. So it's going to be really important for us to make some sense of this. Okay, big idea is we have a model for revenue. By the way, revenue is how much money you bring in when you sell stuff. And X is the number of price reductions that they can make. The big idea here is that if you charge less for something, you can sell more of them, which is really cool because we want to make lots of money. So in this case, Zach and Sarah, without an H, are trying to figure out how to make the most money selling some iridescent piano keys. The big idea here is that the questions don't actually ask you for an X value, but we're going to have to use that X value. So I'm going to do kind of a side problem and say that the max revenue is going to be where X is at a vertex point. And for that, I'm going to say X is equal to negative B over 2A. Again, this is a really important idea for this exam, particularly for this problem. So if X equals negative B over 2A, In this case, that's going to be negative 600 over negative 200, or 3. So the number of price reductions is going to be 3. Zoom up a little bit. I can actually answer my third question easiest from this point because I already have an equation for revenue, and I have x equals 3 is going to be what goes in there. So I'm looking for r of 3, which is negative 100 times 3 squared plus 600 times 3 plus 4,000. Okay? So it's going to be negative 900 plus 1,800 plus 4,000. It's going to be $4,900 is their maximum revenue. Okay, now I've got to use the information in the problem to help figure out what price I'm charging and how many piano keys I'm going to sell. Well, I know that x equals 3. And if the keys cost $20 each, minus 3 price reductions of $2 each, my new price is going to be $14. And how many piano keys will they sell? Well, they sell 200. And then they're going to sell 50 additional piano keys for every increase. So plus 50 times 3 for the number of increases is going to be 350. Again, this is a weird problem that we've never seen before, and you'll never see again because nothing actually is set up this way, except this problem on your midterm. Here's another revenue problem. This one's about Ricky Tikki Tavi selling Cobra heads to his mongoose friends. Just like the one we just did, we're going to kind of do a side problem here. We're trying to maximize revenue, and that's going to be when x is at a vertex. So we're going to do negative b over 2a is equal to x, and that's going to be negative 2,700 over negative 300, and I get that x is equal to 9. Just like what we were looking for before, x is representing the number of price reductions. So we're not talking about x being the number of things that they sell, but the number of reductions that they can make. Again, I find it easiest to start from the maximum revenue and then move up to the other parts just because we have x and we have an equation. So r of 9 is negative 150 times 9 squared plus 2,700 times 9 plus 13,200. Okay, negative 150 times 81, I don't even know. That's going to be 343 times 50, which might be nice if I actually had something open that would let me do a calculator thing, like the Google or Desmos. So negative 150 times 81, so negative 12,150 plus 27 times 9 is going to be 2,400 plus 13,200. When I add these things up, so 24,300, 13,200, I get 25,350. And that's in gems, because that's the unit that he's selling these things for. What's the price that will allow Rikki-Tikki Tavi to maximize his revenue? So again, we did x is equal to 9. It's the number of reductions of price. Currently, there are 11. And if we subtract 9 times, and we said price reductions of 0.5, that's going to be 6.5. Okay. How many Cobra hoods will he sell? So it's 300 Cobra hoods additional. So we're looking at 1,200 plus 300 additional hoods times 9, and that's going to be 3,900 Cobra hoods being sold.